Okay guys and girls, welcome to another exciting episode of Chemistry Revision. For those of you that don't know, I'm going to be doing AQA Chemistry, Biology and Physics tutorials. What we're looking at today is the properties of metals and non-metals as well as isotopes. Now, like you already know if you've been following these videos, I don't like the way they've been ordered and structured in the AQA book, so I'm changing the order a bit so that it can flow and your knowledge can increase in steps that make sense as opposed to the kind of random way they've put this book together. So, what we're going to be looking at today are metals and non-metals. Now, we've already seen metals and non-metals, so it's a good opportunity to do a recap. Okay, so here is the periodic table, and straight away you need to be able to identify where the metals and where the non-metals are. I'm going to give you a second to just think about it. Right, can you identify where all the metals are and where all the non-metals are on this periodic table? Now, what you should have said is that there is a stepped line from aluminium all the way down to polonium. Right, so I'm just going to decrease the opacity, and so you should have said that here is the stepped line starting from aluminium and going all the way down to PO. And what you should have also said is that anything on this side of the stepped line, right, so everything here are metals, and everything on the opposite side are non-metals. So all of this on this side are non-metals. Okay, so that's the first distinction you need to be able to make. So I just want to make it absolutely clear so that nobody is under any mistake or any illusion or any misconception that this middle block here, so I'm just going to highlight all of this in green, that this middle block, this is known as the transition metals. Transition metals, and we'll revisit these some other time. However, generally you need to know where the metals are and where the non-metals are, and this will be very, very important later on as we look at ionic and covalent bonding. So what I want to do is I want to draw a table, and my table is going to have two headings. The first heading is going to be metals, and the second one, have a guess, that's right, it's going to be non-metals. And you need to be aware of the properties of each one. Now, metals can conduct electricity. So in other words, electricity can flow through them. So number one. Number two is they have a high melting and boiling point compared to non-metals. Melting and boiling point. So I'm just writing BP for short, but that stands for boiling point. So melting point and boiling point. Number three is metals are ductile. What this means is you can stretch them out to make wires. So you can stretch them out to make wires. And number four, finally, is they are malleable. What does this mean? This means that they can be hammered into shape without breaking down. Right, and so if you know what the properties of metals are, then all you have to do is do the opposite for the non-metals. Okay, so number one, can they conduct electricity? No, they can't. So non-metals cannot conduct electricity. Number two, they have a low melting and boiling point. So I'm going to write MP for melting point and BP for boiling point. So they have a low melting point and a low boiling point. Number three, non-metals are brittle. So this is linked with the idea of malleable. So in other words, you cannot hammer these into shape. So the next topic is isotopes. Now, in order to understand what isotopes are, we need to look back at the periodic table. If we take carbon as our example, right, if you look at the top number it's 12, and if you look at the bottom number it's 6. So I'm going to write carbon 12 at the top and 6 at the bottom. Let's just do a recap, guys, so that we are constantly in the know about what these numbers are. This here is the mass number, right, and this shows the total number of protons and neutrons. This here is called the atomic number. And the atomic number, what this shows is how many protons there are. But remember, this is equal to the number of electrons. And if you remember, this is the short way of writing electrons. Now, why are the number of protons and the number of electrons equal in number? Because if you remember, the protons have a positive charge, so they have a plus charge, and the electron has a negative charge. So if you have the same number of protons as the electrons, the overall charge are going to cancel out, so your overall charge will be 0. So let's say, for example, you have 2 protons and 2 electrons. So you've got 2 plus here and a 2 minus here. You've got a charge of plus 2 and a charge of 2 minus. When you add these two together, your overall charge is 0. And you can do this with any two numbers that are the same. It's going to give you the charge of 0. Now that's important in understanding what an isotope is, because an isotope will still have an overall charge of 0. So if it's going to have an overall charge of 0, what can you tell me about which two subatomic particles are going to be the same? The two subatomic particles that are going to be the same in an isotope, as well as your standard element, so this is not an isotope, this is just your standard carbon-12. In both examples, the number of protons and the number of electrons are going to be equal. So if you've got 3 protons, you're going to have 3 electrons. If you've got 4 protons, you're going to have 4 electrons. If you have 1,000,000 protons, let's pretend, you're going to have how many electrons? 1,000,000. It's always going to be the same number. So remember, the protons and electrons are always the same. Doesn't matter whether it's an isotope or not. This is your standard carbon-12. Now we can have an isotope of carbon-12 called carbon-14. Okay, so in other words, the top number is 14, but the bottom number is still 6. Remember, the number of protons and electrons are always the same for the given element. So for carbon, the number of protons is 6. For this carbon, even though the top number, the mass number has changed, the proton number is going to be the same for carbon. So if we look at this now and we work out our pen number, our protons, electrons and neutrons, right? Remember, to work out the number of protons is from the bottom number, so that's 6 protons. It's going to have the same number of electrons as protons, so that's 6 again. To work out the number of neutrons, we're going to do 12, take away the 6, which is equal to 6. We've got 6 protons, 6 electrons and 6 neutrons. Now let's work out the pen for this isotope. So again, we've got 6 protons, we've got 6 electrons because it's from the bottom number again, remember. Now to work out the number of neutrons, we do this time 14, which is the top number, take away 6, which in this case is going to be 8. So this isotope has 8 neutrons, whereas this carbon has 6 neutrons. So how do we define an isotope now? So we need a definition for an isotope. So the definition of an isotope is that an isotope has the same number of protons, the same number of protons and electrons, but a different number of neutrons. And if you look here, that's exactly what we're saying. See, carbon carbon 12, right? This carbon 12 here has 6 electrons. This carbon 14 also has 6 electrons because it's carbon. It's going to have the same number of protons and electrons. So it's got 6 protons, 6 electrons. The same as this carbon, 6 protons, 6 electrons. But what's different is the number of neutrons. Here I've only got 6 neutrons, whereas in this carbon I've got 8 neutrons. So again, an isotope is where the number of protons and electrons are the same, but the number of neutrons are different. And so that's our definition, and that is what an isotope is. So I'm going to give you another example, and I want you to work out and explain why, if at all, they are isotopes. Right, so I want you to look at this. I've got nitrogen 14 and nitrogen 15. I want you to tell me whether or not, using the pen method, these fit the description or the definition of an isotope. Pause the video, see if you can figure it out yourself, then unpause it and see if you got it right. Now, what you should have done is you should have done the pen number for each one. So let's do the pen number for nitrogen 14 first. PEN. So the protons from the bottom number, the electrons is the same as the bottom number, the number of neutrons is 14, take away 7, which is 7. Now let's do the pen number for this here. We've got PEN, protons, electrons and neutrons. The number of protons from the bottom number, which is 7. The number of electrons is the same as the number of protons, so it's 7 again. And neutrons is going to be 15, take away 4, which is 15, it's 8. Now, does this fit the definition of an isotope? Well, if you look at this protons and electrons, it has 7. If you look at the protons and electrons of nitrogen 15, it has the same. So straight away, same number of protons, same number of electrons, it does. And does it have a different number of neutrons? Yes, it does. And so this is an isotope of nitrogen. So an isotope is something that has the same number of protons and electrons, but different number of neutrons. I'm going to give you one more example, see if you can figure this out. So I'm going to word this in a tricky way, just to see if I can catch you out or not. So, what I've got is I've got carbon 14, and I've got a mystery element. I do not know what this mystery element is, so I'm going to call it X. Now I'm calling this X because I don't know what it is. Okay, so we need to identify whether this is an isotope of carbon or not. So it's got a top number of 14 and a bottom number of 7. I want you to pause the video, have a go at the pen method, and then explain whether this is an isotope of carbon or not. So let's look at this. If I do the pen number for this, PEN, so how many protons do I have? I've got 6. How many electrons? Same number. How many neutrons? It's 14, take away 6, which is 8. Now let's do the pen number for this one here. I've got PEN. How many protons do I have? I've got 7. How many electrons do I have? Well, it's the same number, the bottom number. And how many neutrons? It's 14, take away 7, which is 7. So this carbon has 6 protons and 6 electrons, but this one has 7 protons and 7 electrons. So because the number of protons and electrons are different from carbon to this mysterious element, this is not an isotope. Because remember, an isotope must have the same number of protons and electrons, but this one has a different number of protons and electrons. So this is straight away not an isotope. Now you could have just looked at these bottom numbers and saw that they were different and said, yeah, I know that they are not isotopes. Let me put it another way. Let's see if you can work this out. I've got, here, I'm going to stick with carbon 12. I did tell you right at the beginning I like carbon. So I've got carbon 12. I've got this mystery X element, which is 14 and 7. We just looked at it. I've got Y, which is 18 and 5. and I've got Z. These are all made up elements. They're all mysterious elements that I'm just curious about. I've just discovered. I'm making discoveries, guys. Now I want you to look at this and tell me, just by looking at it, which two are isotopes. Pause the video, have a think, and then unpause it. So what you should have said, just by looking at them, is that this one here and this one here are isotopes, because they have the same number of protons and electrons. This has 6 protons and 6 electrons, this has 6 protons and 6 electrons, but it's going to have a different number of neutrons. So the neutron count here is 12 take away 6, which is 6, and the neutron count here is going to be 20 minus 6, which is equal to 14. So you've got the same number of protons and electrons, which is 6, same number of protons and electrons, which is 6, different number of neutrons, and that's our definition of an isotope.